All right. Hey, everybody. It is Friday. A little bit out of schedule. I actually, past couple days, been working on the my talk for Zephyr Development Summit. So that had to get recorded first. Crunch time. But thanks for being here. Just make sure this is hitting on YouTube. Not yet, but it will. I hope so. We'll be going over today out of tree board definitions, a little of an announcement, and then any questions, and we'll wrap it up. And of course, I will. Let's see. There we go. If you haven't already, subscribe and hit that like button. And if you have any questions, comments, leave them down there, because they actually help form what my next live session will be. So if you have something burning, some burning desire that you need to, something that you're having trouble with in Zephyr, it might become a topic of a live session. So definitely check that out. And for some reason, this is not hitting on YouTube. Okay. Oh, wait. Oh. Just making sure that things are, we got audio. I'm having trouble with in Zephyr. We got a delay there, just making sure that people can hear me. That would be bad if that weren't the case. All right, let's jump in. Dun, dun, dun. And also the announcement was that the Zephyr Developer Summit is next week. If you're interested in joining online, I think it's $50 and $15 for academic. So reasonable. And you can also join in person if you'd like. They do have some like late join tickets or however that works. So if you're in California, specifically in San Jose area, then definitely check it out. So we'll be talking about custom boards today. If you have, let's say you're working on a project and maybe you do not want to share with the rest of the world, but you need to create a board definition, it's not that big of a deal. You can actually create your board definition and place it within a module, a submodule within Zephyr. So we'll be going over that today. So what we'll be doing, I'll just show you what each of the files are necessary kind of to create a simple board definition for an NRF52 board. NRF91s are a little bit more complicated. There's a couple more files involved, but once you get the basics, you can kind of move to the next level. The biggest thing here is when you're creating the board definition, make sure that your processor is actually supported in Zephyr. Kind of a big, important thing. And you can also reuse, which I'll be going into, is like if there's a board definition that already exists that uses your processor, that's a great template for you to use for your own boards. So keep that in mind. And then if you do find yourself like you really do want to release, maybe you have an open source design, maybe you're selling it somewhere, you can actually submit a pull request from the vanilla Zephyr repo, which I did. That's what I did with the Circuit Dojo NRF9160 Feather, and you can actually get it locked into the Zephyr tree, the main SDK, which is kind of cool. So the biggest thing here is we're going to be setting up. Hopefully this makes sense. So you can have a repository with a West file and some samples, or one application, and you can just run it, you can compile it, run it, it'll search for everything. Now what you can do is also you can embed drivers, you can embed board definitions, you can embed bindings. So all these things, normally without anything telling it to do, West will not look for them. But during the compilation process, if you have these defined in some type of file, in this case it's at your base directory, root directory in your module, you have a Zephyr folder, and then a file called module.yaml, YML or YAML file. This will help direct the compilation process, the pre-processing, to actually search through your module, your repository for anything else that that might be useful, like a board definition. So we will be creating that module.yaml because it didn't exist before, and then or actually it did in this instance, but for anybody else who's starting from scratch or maybe has a sample application but doesn't have a module, I'll just show you how to do it. And then yeah, you just update the contents of it to make sure the pre-compilation process will actually find it, and then let's see, copy another board definition, and then yeah, what I was saying before about copying a template. Just a long-winded way of saying that you can basically reuse somebody else's work, because the board definitions aren't really proprietary. It's just like, hey, here's the thing that how I set up my board. You can, a lot of times, like I've used the Nordic, when I first used my board, I just used the NRF9160, I think the SDK to form mine. So it's a great way to just get started, especially if you're just like kind of mucking through and trying to really understand device tree and creating a device. So here is the module YAML file. I pointed out like the two things above there. Like if you have other drivers and things, you'll definitely need the CMake and the KConfig. Those are just pointing to your module level files. The important thing here is that settings and then the board root, and that will tell Wes that you have a Zephyr, that you have a boards folder, and then it'll search in that boards folder for actually board definitions. That's the most important thing here, beyond the fact that you need to have that module.yaml in the Zephyr folder. So here's the structure. So I put this just as a test in the NRF9160 Feather examples and drivers, and I just created that boards folder, and it's organized by the processor type. So we can jump into that at the end here. I'll just kind of run through what it looks like in the Zephyr repo and versus like what I have here. But you can see all the important files. You see that I use the NRF9160 or NRF52840 board defs, and I actually didn't rename them. So later on, you'll see that they're renamed. So yeah, definitely all the credit goes to Nordic on that, of course. So the first thing was creating the board.CMake, and this basically just allows you to set how you'd like to program the board. So each of these files have like different purposes, and they're all kind of very similar. So it's sometimes like, why does this file exist exactly? But this one in particular, people I've looked at a couple of them, and they're all basically pointing towards whatever programmer you want to use. The next one is the KConfig. So this is a board-specific KConfig, and you can see that we're enabling the onboard DC to DC. It's set to default. So this allows you to, in your application code, if you want a board-specific, maybe you don't want the DC to DC. Maybe you don't even have those components hooked up. So that's a way you can disable them. So it's just one option there, and I know some code uses it, but you can see it's selecting a further down definition, the SOC DC NR52X. So we have the KConfig.board. So this is where if you've looked at some of the samples, sometimes you'll see that you'll have some code that is board specific. On the NRF or the NCS repo, you'll see some of the samples actually have like a thingy 91 versus a NRF 9160 DK. This allows you to use that config _ board CS test board. Basically, you're defining that variable. So that variable is also a lot of the other configurations and defaults and things like that are dependent on this. So you're just going to make sure you're uniform in the naming, and it's close to your board name. So I'm just using the same board name in this case. It's just the CS test board. But that also puts the dependency on the actual processor. So the SOC NR52840 _ QIAA. So, but it's great because if you have a sample or something that you you have a specific thing for a specific processor, then you could do that for that board, or you can go even lower down to, you can actually specify by that processor value in your code for any conditional like preprocessor macros and stuff like that. So, and you can see that I've already used it in this one. So this is the def config. This is kind of a pseudo KConfig file essentially, and we're just defining some more things like if it has USB, we're going to turn it on, or turn the USB stack, and configuring the Bluetooth controller, things like that. They're just like setting some defaults on the KConfig side where it's actually being like you have the board defined there, but this is where it's like fuzzy. It's like there's also a default config file. So this is kind of like a default KConfig, but then we go to the config file. So it's kind of crazy. So here's that default config file. This is where I would put most of like the same defaults, where these are the things that are going to be on or off no matter what. So it's like they enabled like Sega RTT, serial, GPIO, hardware stack protection. You can also see that if you look at the top 3 lines, like here, over here, over here, over there, but you can see that it's also enabling that board file name, which is the one that I kind of mentioned a couple slides ago. So, but this is where if you design a specific feature in your board, this is where you would say, all right, I want this feature to be on all times. On the other side, if you're on your application side, then you can also turn it off if you want to on a board configuration overlay. That's always an option. So, but this is like I have had to turn off some of these defaults on certain projects just because like maybe I don't want to turn on serial, maybe I don't want to turn on Sega RTT, things like that. So these are just your same defaults. These are the things that are always going to be turned on in most cases. So, and finally the DTS file. So we've gone over overlays a lot. So this is kind of like the base. And this is the base of your device for enabling or setting up any of the P handles, all the default devices, things like that. And then whenever you create an overlay, you're actually editing that. You're basically modifying the default board file, which is that DTS file. This is the important part, is that it also references the kind of like the baseline DTS definition for the processor that you're using. So it's kind of stacked. So you have that processor level DTS, device tree binding stuff, very technical. And then you have the next level of that, which is the kind of the board level, and then you have your project level. So it kind of builds on each other. So hopefully that makes sense, and you can dive in and actually check out some of these things when if you have to create your own. So. And then I actually just like showing that it's like showing up in my, so this is using my VSCode plugin for Zephyr. It does actually show up when I do a change board command. So just, there it is. And but you can also just invoke the west build command manually, and it just shows that it did complete a build on like the basic Blinky sample, which is like my main goal. It's like, hey, well, I just like copy and change some names and then build it. It's a good smoke test to make sure that's actually working. In this case, the Blinky uses like one LED. As long as you have one LED defined, then you're golden. Then I'll run through. I do see a question here. So Amir, how did you try to build MCU Boot on a sample of some board that's not NRF? I'm trying to build flash over serial, but something's missing. So the NR52, 840, everything else works fine. So it's interesting that you did mention that, because I did run into some things when I was doing my NRF SDK or the brain fart, the Zephyr Development Summit presentation. So I had this board, wherever it went, it's missing. But the LoRa board that I was using, it uses an STM32 chip. And there's actually some important differences between the different types of SDKs. So I had to use the vanilla SDK for that STM32 versus for anything that's NRF related, I'm using NCS. And what Nordic does on NCS is they actually, there was actually a bunch of CMake magic wizardry that happens on the back end. When you enable the bootloader, it'll automatically build the bootloader and merge it with your application, and like sign your application, and that all gets merged together. So what you're probably running into is that when you build your application, maybe even with MCU Boot on, that you're actually you're only halfway there. So on vanilla Zephyr, you actually need to go to the MCU Boot directory and go to I think it's like build, or I can actually pull it up here. I'll change cameras and I'll show you where it is. If you go to the bootloader and then boot and Zephyr, that is basically the equivalent of the the sample, like the application for the bootloader. So you can see, like in that boards folder where all the overlay stuff is, like you can see that Circuit Dojo, Feather, NRF 60. There's some bootloader specific configuration in there that just gets saved. So the big thing here is you need to build this with your board and then load it to your device, and then build your application, sign it properly, and then load it over MCU Boot. So two processes for anything that's not NRF, NRF 91, NRF 52, especially if you're not using NRF Connect SDK. So, and I've already tested it. For anything that's not NRF related, it will not build if you use NCS. It'll just break. And I didn't really have time to fiddle with it and try to see if it would actually build for you. But in general, Nordic has some licensing things that you probably shouldn't be using it anyway. I believe the licensing for their code is all hardware specific. You're only allowed to use it if you're using a Nordic-based chip. So hope that answers your question, Amir. But we'll dive into back to what we were talking about before. And I'll make this a little bit bigger so you're not like squinting and like having a difficult. So in the Zephyr repo, and I've kind of gone over this before, I think, but if you go to boards, you can see all these different board architectures. And the one that we're using is just the plain old ARM one, but you can see you can make any board you want as long as it fits within this bucket. Then you got ARC, ARM, ARM64, all these POSIX, RISC-V, Shield, Spark, blah, 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 blah. And you can like scroll down and actually, excuse me, you can find a board that uses the processor that you already have. So like the NRF 9160 Feather, this is the board definition for that guy. You can see there's a lot more files compared to the NR52. You can also scroll down. I think the NR52 SDK, yeah, it's right here. So this is pulled right out of here. This is the NR52 SDK. You can see all the other fun stuff that's inside here. They also have some extra things like documentation, which you don't necessarily need for maybe something that you're developing internally. But if you are pushing it to the Zephyr vanilla repo, the main repo, then they'll probably ask you for documentation. You can't just like push it up there without anything. So, but you can see like there's some the RST file, the structured text file, restructured text, I think it's called, and it's just a bunch of ASCII, kind of similar to Markdown, and images and things like that. But going to so in EdFed, we're gonna just run through those files that I was mentioned before. We have that module, that YAML, so that's living in. I can go to the top level here. So you have the EdFed directory, whatever name of your application, your module. You go down to Zephyr. You create the Zephyr folder if it doesn't exist. and then create that module, that YAML file. And the most important thing here is you have to have that build and then settings and board root. If you don't have any other, if you don't have any other module level configuration or CMake lists. In most cases, you probably don't. You're just probably just setting up your application. So that allows Wes to actually go into you have NFED, or you have the boards directory. I've created a subdirectory of ARM, so because it's an ARM chip, and then created the folder that's the same name, that kind of keeping it namespace throughout, just like it's a CD underscore test underscore board. And you can see I've renamed everything to account for that naming. So, and we went through this guy. This is the one for programming. This is the default like configuration, like if you have a .conf file, but it's a kind of baseline for the board itself. You have the device tree definitions for all the different features of the actual device. PWM, buttons, blah 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 blah. I didn't change anything in here from compared to the Nr52 DK. Oh, and this guy is for their. So there is some type of the Zephyr CI will actually go through and like check some of these things. I haven't jumped into this as much. I haven't used it really yet, but this is here. This YAML file is here for doing some type of CI checks, which I haven't played with a lot yet. So, and maybe somebody out there actually knows with more detail what it does. But I'll probably be getting into that soon. I'd love to get into more kind of testing and things like that, because it's very useful, and especially for CI. So I've already gotten like things for CI for testing and just making sure things build correctly, but also tests would be great. And all that CI, if you're, let's see, do I have it? Did I talk on CI? But you can see I have like my little GitHub workflow here for testing the NRF 9160 drivers and examples set up. So, and we have that like that KConfig for the specific board. You have the board definition, the naming of it, and then you have that defconfig, which is just selecting or setting default some of the underlying configuration stuff. So, but that's creating a board file. And the cool thing is you can tweak that DTS file however you need to, because that's the biggest thing you're going to be changing a lot of. Is maybe you can use the same defaults in the default config files, but for the DTS, that's where you're like changing pins and setting up interfaces that you might be using for that specific board. Maybe you have a UART that's dedicated for a specific sensor or another processor. Maybe you have an I2C that's using connecting to a specific sensor or whatever. And so you have some options there to make it kind of however you want. It's your board definition. Like make it yours. So this is great for anybody who's creating kind of a product that's they don't want to get published out to the world. Maybe it's internal. Maybe it's just something you're working on quietly. You don't want to share it with everybody else. Well, you can just put it right within your application code, which is great. So setting up, setting up the boards, you can copy over a pre-existing board. Like I mentioned before, I think this is the biggest thing you can do just to get started. That's easier than just creating everything from scratch. And that will give you inspiration on how you want to organize things and what you want to use and what you want to not use. And make sure everything is named correctly. I stress the naming convention, that just make sure that everything is named correctly, or else when you do a build, it'll just bork and it'll just yell at you, because it's like, I can't find the default config, I can't find the the DTS file, things like that. And in the end, your quick test is always just to compile and use that board as the target, and make sure it just builds properly, and also that it runs properly, so you can load it to the board and see if it actually blinks, if you're doing blinky or whatever. So, but that's it for this one. Let me see if there's any other questions. Amir, thanks. Yeah, no problem. But I'll try to be getting back to a regular schedule here. Things have been a little bit crazy. I try to at least do one of these a week, but sometimes it's tough, especially when the ZDS presentation was a little bit longer. It's almost an hour. So, but definitely check that out. I think that'll get posted eventually on the Zephyr YouTube, and if it doesn't, I will post it on my channel, considering I have it here. So that's it for this one. Thanks for being here, and we'll make sure if you have any ideas or things that you'd like to see on this channel, jump down in those comments, send me an email, and let me know what you'd like to see, because this is all about you guys. And then sometimes I get little inspirations and little things that when I'm playing, but a lot of it is, like 90% of it is the community. So that's it for this one. Thank you so much, and see you in the next one. And let's see, I got another comment. Leave you. Hi, how are you?